Welcome back to the fourth and final video of this series. This one will be a little bit longer because we have a bit to go through. To start off with, we are going to do our final model, our forest-based classification and regression. We're going to use that boosted form that the example tutorial used. We're going to train only. Model is forest-based. In this case, we aren't going to use the ones that passed ER. We're going to use the variable one. Because in our example, we had some that failed multicollinearity and probability, but that is not an issue with forest-based classification and regression since it's not a linear model. We do want to take out the ones that failed due to nulls, only because it would only run the number of records we have, and that one right here, I think, lost like 65% of the data, so we're going to keep that out. So we only need to remove the two that have the number 100,000 in it and this percentage of teens and young adults. So go ahead and we're going to go to explanatory training variables. And we can check them all, except don't forget to uncheck the ones that aren't variables, like the name and the code. Physically unhealthy can stay, but the mentally unwell, poor mental health has to go since that's our dependent. That can stay, that can stay, that can stay. These can all go. And then this one, that percentage, actually no, those are already gone from before. So yes, all of these can stay except for our dependent variable and then any of those ones that we carried along, like state abbreviation and name. One of these is in here twice. I don't see it twice. Let me check again. Physically unhealthy, BMI, smoking, high housing costs, kitchen and plumbing, overcrowding, non-native English speakers, 16 and looking for work, and census-defined areas. Variable number V036 is repeated. Oh, physically unhealthy days. Should have checked that to begin with. Because I did that one instead as my variable to predict. There we go, all fixed. I'm gonna leave this in. It's always important to be able to troubleshoot. Then we don't have any distances, rasters. We do want an output trained model file, so we'll just call this FBCR1. Should really only have to run one, but just using the same naming scheme. For additional outputs, we do want the training features in the importance table, so we can just call this training. We can call this variable. For advanced model options, we're going to leave this the same, but for our validation options, we do want to run 20 rounds of validation and calculate uncertainty. Now I am and then just call your validation table validation. Now I am definitely not going to run this in the video. This will take a few minutes with 20 runs for validation. So when it is complete, and you do have to be patient, wait for it to be complete, you will get several things. You will first of all get your residual map. Something else is turned on, like that's not changing. All right, so let's go back. So you did have this map, and now you have this map, which is your standard residual map. Now keep in mind, because this isn't linear, it doesn't use spatially weighted data the same way that geographically weighted regression does. So remember, that's why one isn't necessarily better or worse than another. You will also get your prediction interval chart. And this is a pretty smooth curve like the one in the example. So our overestimations and our underestimations are about the same. You will also get those tables, so distribution of variable importance. And you can see that some of these lower variables didn't really affect the overall result. I'm not going to make you run it again. Taking those out is just minor tweaks at this point. And then finally, your validation. And we do have that R-squared value of 0.83. So it's a little bit lower than our geographically weighted, but that makes sense since we are looking in a geographic area. Okay. So what you need to report for this is your map of residuals, which we have, your top variable importance, that is going to be in the messages. So here's our messages. So you do want to report this top table, or not this top table, this top variable importance table. So just screenshot this one right here. And you can see that really only a couple of these mattered in this particular training model, but we did use them all. So we could have taken out probably these bottom ones, but again, don't have to worry about doing that. You need your R-squared value, and this is important. It needs to be from the validation data, not the training data. The training data one should be very, very high because you're modeling against itself. The validation is the 10% that was kept out of the model to test against it. And we do have a lower value for this at 0.776, but that is the R-squared value that we got for this one. Again, we could probably improve it by taking these out. And that is it for the forest-based. All right, so lastly, we are going to do the predictions and make a comparison of the three models for our data. So simply put, you're going to run one more generalized linear, one more weighted, and one more forest-based. So starting off with your generalized linear regression, and I'm going to do this very quickly because you should be pretty familiar at this point. Your input, I did make another copy of my data just to have it fresh. So we have our 2025 health example that I'm going to be using for all of these prediction models. And I'm just going to call it mental health this time. So I have my GLR prediction, my GWR prediction, and my FBCR prediction. So input, these are variables, dependent variable, select the correct ones. The only thing you do need to do is check this prediction outputs. You need to do a output predicted features, build that in, and that will give you this map instead of your predicted values. Oh, not that one. That's geographically weighted. This one, which looks, again, very, very similar, but this is the generalized linear regression. And your linear regression, you will need that R-squared value. In which case, found that to be 0.74 or 0.70. When you run your geographically weighted regression, it's very, very similar as well. So there's our data variable. You'll check your variables. You already know the ideal number of neighbors, so just do number of neighbors, user defined, whatever you used the first time. But you will have to choose that prediction option. And again, when you put your output predicted features in here. All your variables will match. We don't have any additional options here. Go ahead and run that one. You'll get this report. Remember, use your adjusted R squared 0.92. This one is much more accurate as expected. And then finally, your forest-based. This one's a little bit more complicated. Not much though. You do have to choose predictive features and then go about the same process. So training data, variable to predict. You'll choose your variables here. And then for your input prediction features, you're going to use the same layer again. I know this seems a little redundant, but since we don't have anything else to predict from, we're just going to test the models against themselves. So make sure you put the same variable in here, and then you'll do your output prediction. Same additional outputs. You want those two tables, and you want your validation tables as well. 20 runs. This one's going to take a while as well. You will get your output map. So this is the only one that isn't orange for some reason. It's green. But there you go. You have your predicted values. And then you get your messages. You don't need to report your variable table again. You just need your R squared from validation, which is 0.84. Once you have those three, you are going to have to join them all into one table. It doesn't really matter which one you do. I chose to do the generalized linear regression. So you will need to run two joins. I did go into the fields and update these names. So right here you have predicted, which is your GLR. When you do the join with the GWR table, you're going to have predicted 1, which I renamed. And then when you do the forest base, you're going to have prediction 1, 2, which I renamed. For the joins, it's pretty straightforward. You are going to join field. You're not going to add a join. This will allow you to transfer specific fields. So your input table both times is going to be that GLR prediction. In this case, your input field. Oh, I hit everything. One second. You do need your source ID checked to run this. I hit it when I was looking for everything, but you do need that. So just go back. So again, input table is the prediction. The field is the source ID. The join table is the weighted regression. Source ID again. And then we just want the one field. All we want is the predicted V145 value. And so you're going to go ahead and run that. And then you will get this column. You'll run it again for the forest base. So if I change this, there's my prediction, source ID again. They're actually all named the same thing. Nothing changes. Once you have those, again, go in, change those aliases, just so you can tell what in the world you have. Also, they need names. And then lastly, you are going to do a box plot. So you're going to right click, create chart, and in this case, you want to do a box plot. So you'll see this one right here. Maybe. There it goes. And I would go ahead and dock this full screen. And then you will want an image of this box plot. So what this is showing you is the where the values are centered. And they're all about the same because they're kind of predicting themselves. But You will notice that there are different ranges. So the forest-based actually has the lowest range, the generalized linear has the highest range, but the geographically weighted actually has the best R-squared. You will then also want to export this GLR prediction, and you probably just want to call it predictions in general because you want to have access to those three values in your pop-up. So what you would do is probably style this map by the actual value and then have in your pop-up your three predictions, and you can see how close they really are. I mean, all three models did a pretty good job. All right, that is the end of this series of videos. The last bit of advice I have for you is the document has very, very specific requirements for the final project and also includes a checklist of deliverables. If you put everything in, you should be good to go. If anything goes wrong during the project, please post in the troubleshooting and we will do our best to get an answer to you. All right, good luck and have fun.